Alright, today we're going to be looking at sum and difference identities. This is section 7.4. Okay, so first let's just go ahead and go over what the sum and difference identities are. So we have that sine of an angle alpha plus an angle beta equals sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta equals sine of alpha cosine of beta minus cosine of alpha sine of beta. Alright, then down here are the cosine ones. We have cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. Okay, so even though this is adding here, on cosine it's kind of flipped of what you would think. It's going to be subtraction. And as you may have guessed, when we get to subtraction, it's going to be addition. So it's going to be cosine of alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Right, you won't be expected to memorize this. You're going to be able to have a note sheet on exams. But kind of a nifty way to remember these is that I always remember for sine, and then for cosine, I just remember the addition ones, because the subtraction ones kind of follow, right? Sine's going to be the inverse of what you think it's going to be, and then sine's going to be the same, just different signs. So it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. That's Twinkle Twinkle Little Star. That's going to be on the internet now, so that's pretty great. So let's look at an example of how we use this. So let's say that we're asked to simplify sine of theta minus pi over 2. Okay, so first off, let's go ahead and let's let theta equal our alpha, and let's let pi over 2 equal our beta, and substitute them in this formula that we have up here. Okay. So if we plug those in, then we get sine of alpha minus pi over 2 equals sine of theta times cosine of pi over 2 minus cosine of theta sine of pi over 2. Since we know what cosine of pi over 2 and what sine of pi over 2 are, we can just plug in those values. So cosine of pi over 2 is 0, and sine of pi over 2 is 1. And since anything times 0 is 0, and anything times 1 is itself, what we're going to get is we're going to get 0 minus cosine of theta, which is going to give us negative cosine of theta. Okay, so now we have this nifty identity that sine of theta minus pi over 2, we can just rewrite that as negative cosine theta. Right? So then if we were plotting points for this, we wouldn't have to keep putting in points and subtracting pi over 2 over time. We could just change this into negative cosine of theta. Okay. Alright, so now notice that sine of alpha plus beta doesn't equal sine of alpha plus sine of beta. Alright, so like an example is if we take sine of 30 degrees plus 30 degrees, then that's going to equal sine of 60 degrees. And if we look at the unit circle, we know that that's root 3 over 2. Whereas if we take sine of 30 plus sine of 30, well, sine of 30 is 1/2, and 1/2 plus 1/2 is 1, bum, 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 and root 3 over 2 does not equal 1, which is a big bummer, I'm sorry. And the same goes for cosine of alpha plus beta. That does not equal cosine of alpha plus cosine of beta. Okay. All right. So now let's move on to some examples. So let's go ahead and simplify cosine of pi over 2. Alright, so if we look at our equation that I just had up here that you guys haven't memorized yet. So if we look at our equation, we're going to be using this one, which is cosine of alpha plus b equals cosine alpha cosine beta minus sine alpha sine beta. Alright, so if I let this be my alpha, and let this be my beta, then what I'm going to get is I'm going to get that equals, and I'll write that right over here, cosine of pi over 2 times cosine of theta minus, remember, because we're adding, we're going to subtract here, sine of pi over 2 times sine of theta. Right, and since cosine of pi over 2 is 0, that's going to be 0 times cosine of theta minus And sine of pi over 2 is 1, so that's going to be 1 times sine of theta. So we're going to get negative sine of theta. Okay, so now again we have a neat little formula or theorem or identity. I think it's an identity. That cosine of pi over 2 plus theta is equal to negative sine of theta. Okay, so then another way that we can do, or we can use sum and difference formulas, is that we can find the exact value of cosine of 15 degrees. So what do I mean by that? So we know that we can just enter that into our calculator. So let's enter that in. So let's do cosine of 15 degrees. But see, we get a decimal. So this is only accurate up to 6 decimal points, it looks like. Okay, so let's see what I mean by exact. So I can rewrite 15 degrees as 45 degrees minus 30 degrees. Now, why did I pick 45 degrees and 30 degrees? Well, I picked them kind of for the same reason that I picked pi over 2 up here, is because these are values on the unit circle that we know. Okay, so I could have picked 46 and 31, but that wouldn't have got me anywhere because I don't know the exact values of those either. Okay, so you want to pick values that you know on the unit circle. All right, so then I would use my sum and difference formula, okay, which would be this one right here. So remember, I'm going to be adding here instead of subtracting. So that's going to give me cosine of 45 times cosine of 30. Remember, I'm subtracting, so I'm going to add sine of 45 times sine of 30. Now I can look at the unit circle and I know all of these values. Okay, so cosine of 45 is root 2 over 2 times cosine of 30 is root 3 over 2 plus sine of 45 is root 2 over 2, sine of 30 is 1/2. Okay, and then when I multiply, I'm just going to multiply straight across. Right, so that's going to be square root of 6 over 4 plus square root of 2 over 4. That's going to give me square root 6 plus square root 2 over 4. If you have trouble multiplying square roots or adding fractions, go ahead and review that. There's a cheat sheet on D2L. You can also come and see me. Just doing things like this is going to be super important. So for example, if I gave you this question on exam or on a quiz, I would like to see every single step that you did. The reason is because on some calculators you can enter in cosine of 15 degrees and hit enter, and it will give you the exact number just like this. But I want to know that you guys can do the work. Okay? Also, you don't have to simplify it from here. You can just leave it like this. Also, even though these are all even numbers, so like 6, 2, and 4 even, you can't reduce this any further. So just leave it like this. Okay, let's do another example. So let's find the exact value of sine of pi over 12. Well, now that we're in radians, this is getting a little tough. So let's try to break down pi over 12. Okay, so what I would do is that I would break down what I know about factors of 12. So I know that 12 has factors of 1, 2, 3, 4, and 6. Okay. Now I'm going to look and see which values of these subtract from each other to give me 1. And you're going to see why I do that in just a second. So I could either do 3 and 2, or I could do 3 and 1, or 3 and 4, sorry. Why wouldn't I do 2 and 1? Well, we'll see in a minute. That's not really going to get me anywhere. Okay, so I can rewrite pi over 12 as 4 pi over 12 minus 3 pi over 12. And that's going to give me pi over 3 minus pi over 4. See how those reduce? And pi over 3, as well as pi over 4, are both values that I know on the unit circle. Okay? Whereas had I used just 1, then I would have had pi over 6 minus pi over 12, and I still don't know what pi over 12 is. Right? Let's see if this one works. So let's do 3 pi over 12 minus 2 pi over 12. And that's going to give me pi over 4 minus pi over 6. Okay, well I know pi over 4, and I also know pi over 6. So these values also work. Okay, so you don't have to use unique values when you do these. You just have to use values that you know, and that will work. You could have also changed this into degrees if that was easier for you. This is kind of a good skill to have for calculus. Okay, so I'm going to use this one. Now let's go ahead and work it out. So let's do sine of pi over 3 minus pi over 4. That's going to equal, if I use my handy dandy note sheet, which you should have next to you by now. So that's going to give me sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. Okay, sorry, I scrunched it up a little bit. So I know that sine of pi over 3 is going to give me root 3 over 2, and that cosine of pi over 4 is root 2 over 2, minus, this is 1/2, sine of pi over 4 is root 2 over 2, so that's going to give me root 6 minus root 2 over 4. Okay. Again, these numbers here would be good to keep handy, and we'll see why in the next example. All right, so for the next example, we have 5 pi over 12. Well, I can add 3 pi over 12 plus 2 pi over 12, and that's going to give me 5 pi over 12. So if I reduce that, that's going to be the same as pi over 4 plus pi over 6, which is awesome. Okay, so kind of keep these numbers in your back pocket. They're wonderful to have. Okay, so if we work this one out, we're going to have sine of pi over 4 plus pi over 6. Right, go ahead and take a minute, work this one out on your own. Okay, so that's going to give me sine pi over 4 cosine pi over 6 plus cosine pi over 4 sine pi over 6. Okay, that guy equals root 2 over 2. Cosine pi over 6 is root 3 over 2 plus root 2 over 2 times 1/2. Okay, and my answer is going to be square root 6 over 4 plus root 2 over 4. It's going to be root 6 plus root 2 over 4. Alright, not too shabby. Okay, let's look at another way that we can use these. Okay, so let's say that I'm given that sine of alpha equals 4 over 5 and cosine of beta equals negative 3 over 5. Okay, so these are two different angles. And I'm asked to find sine of alpha plus beta if alpha is in quadrant 2 and if beta is in quadrant 3. So it looks like we're going to be using some trig identities. Okay, so remember, I can solve for cosine of beta, which I'll need to complete this equation. Okay, so remember that to solve for sine of alpha plus beta, I'm going to need sine alpha cosine beta as well as cosine alpha and sine beta. Okay? So since they gave me sine alpha and cosine beta, I still need cosine alpha and sine of beta. Alright, so let's go ahead and solve for those. So the way I'm going to do that is I'm going to solve for cosine beta first. So I know that sine squared plus cosine squared equals 1. Okay, so let's just keep that in our pocket. We're going to need that. So if I do 4/5 squared plus cosine of alpha squared equals 1, then I'm going to get 16/25 plus cosine squared alpha equals 1. Right, now remember, when I solve for cosine, I'm going to get that cosine of alpha can equal either plus or minus, excuse me, is going to either equal either plus or minus 3/5. Well, since I know that alpha is in quadrant 1, then I'm going to get that that equals -3/5. Okay? So let's put a square around that. Now let's solve for sine of beta. So we're going to do the same thing. We're going to have that -3/5 squared plus sine squared of beta equals 1. Then when we solve for sine of beta like we have been before, we're going to get that sine of beta is either going to equal plus or minus 4/5. Okay. Now, because beta is in quadrant 3, right, I'm going to get that sine is going to equal -4/5. Right, now that I have these two important pieces, I'm going to plug them into my formula. So that means that sine alpha plus beta is going to equal sine of alpha, which is 4/5, times cosine of beta, which is -3/5, plus cosine alpha, which is -3/5, times sine of beta, which is -4/5. All right, and then when I do the algebra on that, I'm going to get -12/25 plus +12/25, because a negative times a negative is a positive. When I work that out, I'm going to get 0/25, which just gives me 0. All right, so now when I work out finding cosine of alpha minus beta, if alpha is in quadrant 2 and if beta is in quadrant 3, well, I already know my cosine of alpha if alpha is in quadrant 2, and I already know my sine of beta if it's in quadrant 3, so I just need to plug and chug. So since cosine of alpha minus beta, I'll just rewrite the formula here for you, is cosine alpha cosine beta plus sine alpha sine beta, then I just have to plug and chug. So I have -3/5 times -3/5 plus 4/5 times -4/5 Remember, I'm getting these numbers from both here and here from where I solve them. All right, so now when I follow through with this, I'm going to get that's a positive 9/25 plus, and this is going to give me negative 16/25. Right, and I just work it all the way across since I have a common denominator, so that's going to give me negative 7/25. All right, and that concludes how we're going to use sum and difference formulas. And then next up is Chapter 8.